consider two common processes, a plant photosynthesizing and a candle burning. Both are chemical reactions, and so there is a change of reactants into products. Both processes also involve a change in energy. A change in energy accompanies every chemical reaction. Enthalpy change is the measure of energy change during a chemical reaction. So let us look at each process and see if we can see what is going on. First, the burning candle. The wax is reacting with oxygen, forming a flame and producing carbon dioxide and water. If you put your hand close to the flame, you will burn yourself because it is hot. The flame is giving off heat. On the other hand, the plant is just sitting there absorbing the UV rays from the sun. This time the heat is coming from the sun and going into the leaf. So can you tell what is different about these two processes in terms of energy or heat? Don't worry if you can't quite explain it. By the end of this lesson you will be able to. This lesson is all about heat and energy transfer during chemical reactions. Energy is at the center of everything we do, but it is actually really difficult to precisely define it. I will simply define energy as the ability to do work or produce heat. An important type of energy is potential energy. Potential energy is energy due to position or composition. Potential energy is present in the chemical bonds of molecules. One of the most important characteristics of energy is that it is conserved. The law of conservation of energy states that energy can neither be created nor destroyed. It is converted from one form to another. This law is also known as the first law of thermodynamics. If we return to the candle in the plant, we can illustrate this. For the candle, the potential energy contained in the candle wax and the oxygen is released. It is then transferred into the potential energy of the products. The extra energy left over is transferred out as heat. For the plant, the energy from both the sun's UV rays and carbon dioxide are transferred into the products, which are oxygen and glucose. This time, though, there is no excess energy. In fact, there is a deficit in energy, so heat from the sun is absorbed by the plant to make up this deficit. Heat transfers into the plant. For both reactions, energy is transferred from one form to another. Let us now consider two very important concepts that often get confused: heat and temperature. Temperature is a measure of the random motion of particles. We can easily measure temperature by using a thermometer. The air around the candle flame is a much higher temperature than further away. Heat is the transfer of energy between two objects due to temperature difference. It is important to know that the transfer of heat is always from hot to cold, and never the other way around. In both reactions, heat is either being transferred in or transferred out. Now we are going to consider the direction of heat transfer during a chemical reaction. To really focus in on a specific chemical reaction, we have to divide the universe into two. The system is the part of the universe we are interested in. The surroundings include everything else in the universe. For a candle burning, the reactants and products is the system. The surroundings are the air in the room and anything else. When a reaction results in heat being given out, it is called exothermic. Energy in the form of heat flows out of the system. The candle is burning and energy flows out of the system as heat. Reactions that absorb heat energy from surroundings are called endothermic. Heat flows into the system. Our plant is a great example of an endothermic process. It is absorbing heat from the sun. It is important to realize that the transfer of heat into or out of the system equals the amount of heat lost or gained in the surroundings. Energy must be conserved. So far, we have learned that a change in energy accompanies every chemical reaction. We have also seen that reactions can give out heat or take in heat. But how do we measure change in energy of a reaction? This is where enthalpy change comes in. With our new knowledge, you can think of enthalpy change as the amount of heat absorbed or released by a chemical reaction. Let's look at the enthalpy changes for our two examples. When a candle burns, the potential energy from the reactants has been transferred to the products. Here you can see the potential energy of the system has gone down. The extra energy left over from the reaction is transferred to the surroundings as heat. Remember, the heat gained by the surroundings must be equal to the heat lost by the system. We can measure the temperature change of the surroundings, and we can directly relate this to the enthalpy change of a system. In an exothermic reaction, the potential energy of the products is lower than the reactants. Heat has been transferred to the surroundings, and the temperature of the surroundings goes up. For our plant photosynthesizing, again the potential energy from the reactants has been transferred to the products. But this time the products are at a higher energy. Extra energy is transferred into the system by the plant absorbing heat energy from the sun. Again, we can measure the heat of the surroundings and directly relate it to the enthalpy change of the system. In an endothermic reaction, the potential energy of the products is higher than the reactants. Heat has been transferred from the surroundings, and the temperature of the surroundings goes down. You will notice on each diagram we have a symbol delta H. This is the change in enthalpy. It is very easy to figure out the amount of enthalpy change of a reaction. You can use this simple equation. All you have to do is add up all the enthalpies of the products and then subtract all of the enthalpies of the reactants. The difference between the two is the enthalpy change. If the difference ends up with a negative number, then you have an exothermic reaction. If the difference ends up as a positive number, then you have an endothermic reaction. And make sure you don't lose the positive sign so you are clear which type of reaction you have. In this lesson you have learned that enthalpy is the energy transferred during a chemical reaction. The law of conservation of energy tells us that energy is neither created nor destroyed, it is transferred from one form to another. Temperature and heat are not the same. Temperature is a measure of the random motion of particles in the system, and heat is the transfer of energy due to a temperature difference. In an exothermic reaction, the potential energy of the system goes down and heat is given out. In an endothermic reaction, the potential energy of the system goes up and heat is taken in. The enthalpy change of a reaction is the difference between the sum of enthalpies of products and the sum of enthalpies of reactants. And the amount of heat exchanged with the surroundings can be directly related to the enthalpy change of the reaction.